agree. All right, so if let's go back and write this. So if I have my definition that I just gave you, sine of theta, my plus and minus, and over here I have my minus theta, 1 minus cosine theta. Okay, so that's what I just showed you. That's our definition. Then if I want to find, let's say, find the limit of minus absolute value of theta as theta goes to 0. What's the answer? Yes, say it louder. 0. Can't you just take, that's a horrible looking theta, that's a theta. Can't you just take 0 and just plug it in and I get 0? Well, how about the limit, that's that side, how about the limit of that side of the absolute value of theta as theta approaches 0 is what? Perfect. What did we just do? Our sandwich. So this would imply that the limit of the sine of theta as theta approaches 0 would be what? 0. Now, for most of you, if you're like me and you're really visualizing, and I'm trying to get you to visualize this stuff more, then this would be, why did I have to go through all this junk? Because I know what a sine function looks like. I know as I'm getting closer and closer to 0, in fact, the sine goes through 0, 0, right? I already knew that. That's the hard part of calculus. No, you didn't. You didn't know it in a limit way. You had to actually use this proof, okay, this definition, to get to this. And that's the difficult part for most students is you have already that background knowledge. Remember that we're not saying what is the sine of 0. We're saying as we get close to 0. Well, you didn't know that. You knew what the sine of 0 is, but as we're getting close to 0, that's where the limit comes in. And then, of course, we can do the same thing up here, and the limit, let's do this one a different way, as theta goes to 0 of 1 minus cosine of theta. Certainly, you can use the same, you can kind of look at that up, the same thing that you should get 0 with the sandwich theorem. Well, let's just practice our limit as theta goes to 0 of 1 minus the limit of cosine of theta as theta goes to 0. Okay, this could be on your, I probably wouldn't give you trig functions yet, but this could be on your quiz. What is the limit of 1 as theta goes to 0? Very good. Okay, remember that's our constant. What's the limit of cosine as theta goes to 0? 1, because the only thing you know how to do right now is take that, plug it in, and see if it works. Well, once again, we get 0, so you could have done the same thing we did up there, the sandwich theorem. You could have done it either way. Okay, but I actually wanted to do this way to get you more practice. I don't know why students really struggle with this whole constant one. Okay, to make sure that doesn't throw you off. All right, so note for any function f, the limit of the absolute value of f of x as x approaches c, if this equals 0, implies the limit of f of x as x approaches c equals 0. In other words, I say, don't need the absolute value. Well, why? Because the minus f of x absolute value, f of x, and then the positive, this is sandwiched in between. If from my example, I'm saying as that goes to 0 or whatever value, let's say 0. We'll just leave it as zeros. Then by my sandwich theorem once again, then that has to go to 0. Okay, so whatever value I put C's up here, but whatever value you're interested in, my limit values will all be the same. So in other words, we don't really have to worry about the absolute values unless we're solving something and we have to do that whole plus and minus stuff. Okay, if we're actually trying to solve something. So the last theorem in this section is if f of x is less than g of x for all x. In other words, we're saying g of x is always on top of f of x. They never cross because we say it's for all x. Again, in some open interval containing my value of interest, C. And we gotta always keep writing this except possibly x equals C itself. Why do we have to keep reminding ourselves that? It may not be in the domain, okay? But it's near that value, and the limits of both functions, f and g, exist. We've talked about when limits don't exist, jumps, oscillating, grow without bound. I mean, we'll get into that later, that, you know, what do you do then if a limit does not exist? As x approaches C, then, and this should make sense, the limit of f of x as x approaches C is going to be less than the limit of g of x as x approaches C. This is hard to make your mind not think, well, duh, that makes sense because this function's always above this function. We're not talking about the value of the function down here. We are talking about it up here, but down here we're actually talking about, as we get close to some value C, what is my value, my y, let's say, getting very, very near. And this ends 2.2.